locations for molar mass, as well as doing mole conversions. So I have 3 example problems for us today, and we're going to look at possible locations of mistakes for each of these examples. You will see these possible errors as listed as choices as you go through and work each of these problems. So in the very first example, we're going to be looking at the molar mass of aluminum phosphate. The formula is written correctly for you, but you want to go through and determine if the work that is shown to you is totally correct, or if there is a mistake, and if so, where that mistake is listed. So here are all the possible errors that could happen. The first one is that the molar mass of the element is wrong. So for example, maybe the molar mass of aluminum was off somehow. Another possibility is that the whole compound, when you add up all the individual elements, has an incorrect total. That would mean that the molar mass of the compound is incorrect. Another possibility is that when you went through, when you went through and multiplied these values, if there's more than one, it's possible that the number that's being multiplied is inaccurate. So for example, in the oxygen, it should be multiplied by 4, but maybe it's multiplied by some other number. Now, the very last possibility is that it's done totally correctly, and there's no error at all in the calculation. So we're going to go through and do an example together so you can work through these questions in your practice quiz. All right, so I've got 3 elements here. I have aluminum, I have phosphorus, and I have oxygen. But what I need to remember about my oxygen is that there's actually 4 moles of oxygen. So whatever value I have for oxygen, I'm going to need to multiply it by a 4. I have a periodic table down here at the bottom for us as a reference. So I'm going to go through and look at them. So aluminum is right here. Again, my number that is the molar mass is the number that is directly below the symbol itself. And we're going to go with whole numbers. So aluminum has a mass of 27. Phosphorus has a mass of 31. And oxygen has a mass of 16. So if I go back up here, aluminum is 27 grams per mole. Phosphorus is 31 grams per mole, and oxygen is 16 grams per mole. But what I need to remember when doing this, of course, is that I'm going to multiply this oxygen by a total of 4, because there's 4 moles of oxygen in this. So I'm going to take all of these values, and then I'm going to go ahead and add them up. 27 plus 31 plus 4 times 16. And when I do, I'll get whatever that answer is going to be. So now, where could a mistake be made? Well, a possibility is maybe one of the elements was wrong. So maybe instead of having 27, maybe they said the answer was 37. That would be wrong. Now, if the total number here added up to be something other than what it actually is, that would be the molar mass of the compound being incorrectly. If for some reason I multiplied by a number other than 4, that would mean that the atoms multiply by the incorrect number of atoms would be the mistake. If there is no error in calculation, then I would just mark that as my choice because everything was done correctly. All right, let's take a look at example number 2. So when you do conversions, they can be either 1 or 2 steps in the examples that we're looking at. So the first one is going to be a conversion from grams, right here, into moles. That is a single step calculation, and these are the possibilities that could exist. So first, maybe the molar mass of my element is wrong. So this is magnesium. Perhaps the mass is used incorrectly. It's possible that the conversion factor is accurate, but it's flipped upside down. We'll talk about an example like that. Another possibility is that the values in the units are not correct in the conversion factor. Typically, that happens when we mix up the number that should go for grams with the number that should go for moles. A final possibility is that there is no error at all in calculation and everything is totally accurate. So let's walk through this example together. So if I start with 7.77 grams of magnesium, I always want to make sure that in the bottom of my next step in my factor label, I also have grams. And I'm going to make sure I'm labeling both the unit and the substance. So I have grams of magnesium. I am trying to get to 1 mole of magnesium, and I can do that in 1 step. In order to calculate the grams of magnesium, I'm going to go down to my periodic table, and magnesium has a mass of 24.31 grams per mole, but I'm going to round it to a whole number, which is 24 grams. Now, if I've done everything correctly, everything will cancel out. So grams of magnesium cancel with grams of magnesium, and then I have moles of magnesium on top, which is what I'm trying to get to. So this is actually a one-step question, so I can actually erase this last spot here because I don't need to actually go through and calculate that because I only have one step. So I'd go through and get the answer. Now, in your problems, what you'll see is that there is no calculation for a final answer. We're really just working on the setup. Is the setup correct? Because the final answer doesn't mean anything if you don't have the work to support it. So where could mistakes be made? Well, the first one is maybe the molar mass is wrong. So maybe instead of 24, I wrote 42, for example. That would be the error there. It's possible that the conversion factor is flipped upside down. So if I have something flipped upside down, instead of having it the way I've written, I would have written out 7.77 grams of magnesium. And instead of putting 24 grams of magnesium on the top, I would have put it, on the bottom, I would have put it on the top, and then 1 mole of magnesium on the bottom. Okay, this would obviously be incorrect because it should be flipped around. Another common mistake that is made is that the units and values aren't in the right location. Here's what I mean by that. You need to always put the number 1 in front of moles. But in this case, if I made a mistake, maybe I said something like there are 24 moles of magnesium over 1 gram of magnesium. That's not correct because 1 has to go with moles and 24 has to go with grams. So that would be a mistake there where the values and units were incorrectly connected to each other. Or it's possible that they're just all completely accurate as well. All right, let's take a look at our third example as we go down. So the last one we're going to take a look at is a conversion from atoms into grams. Now this is a two-step conversion, and so there are different possible mistakes that we can look at this. The first is that the units just don't cancel accurately. Another possibility, since I'm working with molar masses, is that a molar mass is incorrect. The next one, which is similar to the last one, is that the values in the units don't match up in their conversion factor. And finally, there's a possibility that everything is actually great and there are no errors at all. So let's take a look how to do this correctly, and then we can see where a mistake could be made. So if I have 5.99 times 10 to the 23rd atoms of silicon, I'm going to go ahead and make sure that if I have atoms in the top in my numerator, in the following denominator, I'm going to also have atoms of silicon. I'm running out of space, so I'm going to just write a little bit smaller. The number that's always associated with atoms is 6.022 times 10 to the 23rd, and that's the number of atoms always in 1 mole of anything. In this case, we're talking about silicon. Now, I've noticed that my atoms of silicon cancel beautifully. That's what I want to happen, but there could be a mistake there that we're going to look for. Now, the last thing is to convert from moles, finally into grams. I want my moles to cancel, so I've got 1 mole on top and 1 mole on bottom in the next step. Notice that the number 1 is always in front of moles when we're doing these types of conversions. Finally, I'm going to need to determine the number of grams of silicon. So I'm going to move down to my periodic table here, and I'm going to look for silicon. Silicon is right here, and silicon has a mass of 28.09, so I'm going to round that to a whole number, which is 28 grams. If I've done this correctly, moles and moles cancel. I have my final unit on top, which is grams of silicon. So now it's set up correctly. Again, I'm not even going to ask you to calculate a final answer. We're really focusing on setup in all of this. Now, where are the possibilities that mistakes could be made? Let's give ourselves a little bit more space here so that we can work through what those mistakes might look like if they do exist. So the first one is that the units don't cancel. So if I were to set this up, and I'd say 5.99 times 10 to the 23rd atoms of silicon, maybe in my second step here, in my first part of the conversion, maybe I put 1 mole of silicon, and then I put 6.022 times 10 to the 23rd atoms of silicon on top. Obviously, atoms and moles right here and here can't cancel. 1 on top, 1 on bottom. They're not the same thing. So that would be an example here of the very first one where the units don't cancel. So these and these do not cancel. Another possibility is the molar mass is incorrect. So if we walk through that one, we said that silicon had a mass of 28 grams. But maybe instead of doing 28, instead the answer had for you, a little hard to see that if I go over it. Sorry about that. I'll pick a slightly different color. Still can't see very well, but let's say that I use the number 35, for example. I use something different that didn't represent silicon. That would be an example of the molar mass being wrong. The last one is that the values in the units don't match in their conversion factor. This is probably one of the most common mistakes that I do see when grading students' work. And so here's what that would look like. If I had 5.99 times 10 to the 23rd atoms of silicon, one of the most common mistakes we see students do is they'll say there's one atom of silicon for every 6.022 times 10 to the 23rd moles of silicon. And then they'll go on and do the mole step with the gram step accurately. We said that it was 28 grams. So that part looks good. But what you'll notice in this piece is that all of a sudden I have this number here, which is Avogadro's number, associated with moles. And I have 1 here associated with atoms. That's not the case. There's always 6.022 times 10 to the 23rd atoms in 1 mole. So I flipped these two numbers. So this part is inaccurate. And so that I would identify that. And finally, last possibility is that it's totally correct too. So you're going to be looking through, really focusing on how a problem is solved. The answer is so small in comparison of looking at step by step, thinking about as I start from the beginning of the question all the way through to the end. Good luck as you take this quiz. Please reach out to your teachers if you have any questions.